Hello, pre-calculus and trigonometry students. I am here to talk to you about how to solve a triangle when it is not a right triangle. Now, what do we mean by solving a triangle? You've done this before. You did this in geometry. It was with right triangles, and what you did was you found all the missing sides and angles. So to solve to solve any triangle means to find all three sides, to know what the lengths are for all three sides, and to know what the angle measures are for all three angles. But in the past, you've only done it with right triangles, so you were able to use things like the Pythagorean theorem, or right triangle trig like SOHCAHTOA, or even the fact that the two acute angles would add up to 90. We can't use those if we don't have a right triangle. Sorry for my circle job there. But we can use these two tools, the law of sines and the law of cosines. And you'll notice what this is there are specific times that I use the law of sines, specific cases. And there are specific cases for using the law of cosines. And it has to do with the information that was given to me. If I was given two angles and one side to start with, because I always have to start with three pieces of information. If those three pieces of info were two angles and one side, I would start with the law of sines, regardless of whether the side was between the two angles, like this, or not. If I was given one angle and two sides, well, then it kind of matters whether the angle the angle given is between the two sides or not. Here is not. It's not between the two S's. Here it is. If the angle is between the two sides that I was given, I use the law of cosines. If it's not, I use the law of sines. Now, you may recall in geometry when we did congruent triangles, and we saw the things that look like this. We said that ASS was not a congruence postulate or theorem. It was not a reason for saying two triangles are congruent. And that's because ASS is something that we call the ambiguous case. And what that means is this. If I tell you two side lengths and then I give you an angle measure that is not the angle between them, there are two different ways you could draw, I should say case, sorry, not cast. There are two different ways you could draw that triangle. So if I tell you my triangle has these two sides and this angle that's not between them, and you say, oh, okay, I'll draw that, you might draw it completely different than me do. There's not just one triangle that has that given information. Okay, so this is kind of a special case, and it's a special case for another video. We're not going to talk about any with the ambiguous case here. We're also not going to talk about any law of cosines problems in this particular video. I have another video that I will link to this video that is examples of law of cosines problems. What we're going to do here is we're going to look at law of sines problems, and that means situations where law of sines problems that are not the ambiguous case. So situations where I've been given two angles and one side, and I need to find everything else about the triangle. Okay, so first thing, let's go ahead and look at what the law of sines actually says. Okay, to start, it helps to be familiar with the idea of naming my three vertices of my triangle, capital letters, and then saying, okay, I'm going to refer to the side across from each angle by the lowercase of the same letter. So this would be side A, where this length would be A, and this length would be B, and this length would be C. Okay? And what the law of sines says is basically the angles are proportional to the sides across from them. In other words, sine of angle A, whatever the relationship is between that, the ratio, and the length A, the length of the side across from it, that's going to be the same for the sine of angle B, the ratio of that and the length across from it, and also the ratio of the sine of C and the length across from it. Now, sometimes you'll see it written just like this. Sometimes you'll see it the other way, in terms of upside down. The side lengths on top, the sines of the angles on the bottom. It doesn't matter. It's all the same. Okay? So either what the law of sines is telling us. And so that's what we're going to use to do these problems. Now, we're not going to use all three of this. Is what we call an extended, you could call it extended proportion or extended ratio. But this is basically, we have three ratios here. We're going to use two of them at a time. So what we need to have in order to do that is we need to have two angles and the side across from it, the side across from one of those angles, so that we have the right information. And remember, that information is either AAS or ASA. Okay? And that's the only way. We'd have to have one of those types of information, or that one I said we weren't going to get into, portion with one of these. If you try to set it up with the wrong kind of info, it just won't work. You'll have too many variables left standing. You won't be able to solve. You'll have too many empty spaces. So let's go ahead and look at this one. Let's say I was given these two angles, and then I was told that lowercase a is 12. Well, remember, that would be the side opposite angle A. So that would be this. Okay? So for law of sines, I need to be able to either have some angle and the side across from it so I can set up that ratio, or be able to find some angle and the side across from it. If I had this side, I wouldn't know the angle across from it. But look, I know 2 angles out of 3. I can easily find that angle. Sine of A over little a equals sine of B over little b. And I'm going to use that to find this particular side right here. Okay, so I'm going to use my calculator. I'm going to cross multiply. It's all going to be good. Okay, so here you can see what I did. I cross multiplied sine of 95 times 12. Make sure you close the parentheses on the 95 there. And then I divided that by sine of 28. Okay, so why did I do that, by the way? Cross multiplying would have given me this. And so to get b alone, I would have to divide by sine of 28. So that's exactly what I did. So I'm trying to solve for b here. Don't forget, if you're using a graphing calculator, these are given to me in degrees. So please make sure you check your mode and check to make sure you're in degrees, not radians. If you're not using a graphing calculator, the default probably is degrees. It'll tell you right up here. But if you are using a graphing calculator, sometimes that is set on radians. Okay, so what did I get again? I got so sidetracked. I got 25.46. So let's round to the nearest nearest tenth and say 5. 25.5. Okay, we're almost there. Now we have 2 side lengths and we have 2 angles. It's easy enough to find this angle. I can subtract the other 2 from 180. So that's what I'm going to do. 180 minus 28 minus 95 gives me 57 degrees. Okay? So now I have 3 angles, 2 sides. I'm almost there. The only thing I still need is this missing side. So what I'm going to do is I'm going to do law of sines again. Now, let me suggest that when you have already found one of the sides, you go back and instead of using a proportion that has these 2 and these 2 perhaps, go back and use the one you already had. The one you were given to begin with. Here's why. This I was given, A is 12. B is approximately 25.5. This is a rounded answer. So let's not use a rounded answer to find another when we're about to round, because that just gets us farther and farther from the most accurate thing we can do. So I'm going to go back and I'm going to say sine of 28 all over 12. Use the sine of A over little a equals sine of C over little c. So sine of 57 over little c. Cross multiplying there. And this works, like I said, exactly the same if you like to set it up with the sine parts on the denominators. All right, c is still not by itself, so I'm going to divide both sides by sine of 28. And that's what goes in my calculator to get c. So I have 12 times sine 57, all divided by sine 28. And that gives me 21.43, so that's about 21.4. So I really should have squiggly lines here because it's approximately 21.4. Make sure you round to whatever you were asked to round to on your problem, not just assume it's the tenths place. They might ask you to round to the hundredths. And now the triangle is solved. I know all the angles, I know all the sides, so I'm ready to go on and do another one. Okay, so here again I was given 2 angles and the side in between them. So that makes that this type of problem if you're thinking of it in that way. Okay, so that's how I know I should use law of sines. And I'm going to go ahead and label these. Let's say QRS, which makes this little q, this is little r, and this is little s. Okay, so I'm going to start by saying, well, I need to pick anytime we're setting up a ratio, if we're trying to set up a proportion, we have to know both the top and bottom for one of the ratios, or else it's not helpful to us. So I'm going to say, I want the angle that I have the side across from it. So like, not this one, because I don't know the side across from it. Not this one, because I don't know the side across from it. So what am I going to do? Well, again, it's easy enough to find the third angle. Okay, so I'm going to subtract 180, because the only side I know is little r. So 180 minus 73 minus 38 gives me 69 degrees. So r is 69 degrees. And now I know an angle and a side across from it. Can't use law of sines unless I know an angle and a side across from it. So sine of 69 over the side across from it equals, let's go with s first. It's up to you which one you want to find first. It does not matter. All right, so now I cross multiply. 15 times sine of 38 equals s times sine of 69. And then I have to divide both sides by sine of 69. And that tells me what goes in my calculator. So that is 15 times sine of 38. I am a big fan of saying to my geometry students when we first learn how to do this, that you don't know what goes in your calculator until you have isolated your variables. So that's why I'm saying it that way. This now tells me that S is approximately 9.9. Okay? Now I'm going to go ahead and find Q. But I'm not going to use 9.9 to find Q because 9.9 is a rounded answer. I'm going to go back and use the one new exactly, which is 15 for R. So let's go ahead and use the same ratio that we started with. But this time set it up with Q. Sine of Q, which is 73 degrees, over little q. And again, I'm going to go ahead and cross multiply. Divide both sides by this sign. I'm sorry, that degree goes in there. So it will cancel. And now Q is by itself, and that tells me what goes in the calculator. 15 times sine of 73, all, did I do it right? No. All divided by sine of 69. I'm doing it all in one. And I get 15.4. Notice that I generally like to sort of do the order of operations for my calculator to make sure my calculator is being told the right thing, like I did the top. Hit enter, and then divide by sine 69. But I was careful the other time I did it with parentheses. Just make sure that you do the entire numerator before dividing by sine of 69. Okay, so 15.4 is our answer. It actually probably wouldn't make a difference here. But now I know all three sides, all three angles, and so I'm done. All right, so those were, we did AAS and we did ASA with law of sines. I'm not going to do any more examples because they all pretty much work the same way. The only other things you need to know about law of sines is how to do the ambiguous case. All right, so keep that in mind for another video if you need to learn how to do that right now. The other thing is law of cosines. Remember, that would be SSS or SAS. But one thing I just wanted to point out to you is one more thing to know about using law of sines or law of cosines is that it's best case, usually best situation, best, I don't know, the most wise course of action is to continue with whichever one you started with. In other words, after I have found one of the missing sides, well then I could say, oh, now I have side, angle, side. So now I'm going to use law of cosines. The better plan is to just stick with whichever one you started with throughout the entire problem. because otherwise sometimes you get into problems with the ambiguous case and not noticing that that has come up. So just wanted to mention that. Hope this has helped, and I'll see you next time.